Alright, hell yeah. So make this video go viral, you know what I mean? Chat it up, give some likes. But anyway, this is a Harvard Weekly problem. Subscribers like, hey, do your style, you know what I mean? Figure it out. He said there was a lot of just mathematical answers. And if you can't prove to the layperson, so check it out. This is going to be our proof. It's one page, booyah. If you can't prove to the layperson, you know what I mean, that this thing's going to work. So you have a rubber band, it's attached to a wall, and it could be, you know what I mean, this long, and you have an ant. And from that, the ant goes really slow, and then you're going to be pulling the rubber band, and you're going to be torturing this ant, because you're going to pull faster than the ant can crawl, but the ant will reach the end. So that is the only thing I knew going into this, is because I looked up the problem, and it was a resounding yes. But still, you know what I mean? It took me a while to figure out how I wanted to explore this, how it's not the same as being on a treadmill. If you're on a treadmill, you know, that's going as fast as you can run, you're never going to reach, you know, the front of the treadmill. You're just going to be in place. But somehow, this problem works where the ant actually gets there. You can read through, but the what was the take-home point is that the band stretches uniformly. And so, hell yeah. And I was just thinking, I was telling my mom, I was just like, oh, hell yeah, I think I can explain this to you as talking about the last step. So, I'm going to say that I'm the ant. And there's going to be a band that I'm walking on. And my speed's going to be 1/10 the rate that you're pulling this band out from underneath me. You know what I mean? So you have a rubber band, and it's getting stretched at 10 meters per second. I can only walk 1 meter per second. So I'm going to analyze this at the last step. And I chose this very particularly, and just lucked out as well. Because I was like, because I already kind of know the idea, and I know none of the solutions. I just know the idea that the constant rate is important. The fact that if I'm right here, oh hell no, I'm just getting pulled 10 meters per second that way, and I'm only going 1 meter. So I'm literally going 9 meters per second that way. But if, for whatever reason, I started right here, well, this point's going 10 meters per second that way, but you know what I mean? And so let's just run this for 1 second. That's also what I like to do in physics, is just like set it up and run it for a second. I'm 1 meter away. Cool, I'm going to take a step. But, you know, it seems like I'm going to get to the wall. But at the same time, this rubber band is stretching at 10 meters per second. And it's going to trip you out. Wait for the end. So in 1 second, this rubber band becomes 20 meters. And you're just like, damn it. Now I'm actually, that means that this stretched out 2 meters, and I only stepped 1. I stepped in the same location. So you might still be thinking, I'm never going to get there. But the cool thing, and after doing this, setting it up to here, I was just like, oh, I found the point at which you will start to make ground. Because check this out. If we're going to run the same scenario where I take another step in 1 second and land 1 meter away, this 20 meters of rubber band would have to stretch to 40 meters. I don't know why I said it that way. But anyway, hell yeah. So, but it's only increasing at a constant rate. So in that second, it only gets to 30 meters. Now, I'm not going to actually, you know, do I actually make 1/3 of a meter? Who cares? The whole objective with this last step solution is to show that at this point, you will be closer. This rubber band would have to go from 20 to 40 meters in a second for you to be just at the same location. You know what I mean? And so there's an equation where if let's not get into that, let's just get into the solution. So because it's less, this distance did not move. You know, this distance did not double. And so therefore, if this is now 1 meter, because we got 30 of these, I am now a little bit closer. And that is enough to set up the next iteration that I'll be a little bit closer as well. But it's not until this point that I'm actually gaining forward momentum. And so this shows that at the proportion, so if my speed is 1/10, the rate of which you're pulling this rubber band that you can pull for a long way. I will not make ground until I get, until my proportion of my velocity, I'm only at 1/10 the speed of the rubber band being pulled out. So only when I'm at a location where I'm 1/10, ooh, damn it. Maybe I'm, yeah, that's interesting. Because at the very start of this, you have a 10-meter rubber band, and I'm like, so I do need to analyze the first step. But I think this is good enough for me to be like, hey, so maybe this is just half the puzzle. Because I still don't see how I'm actually going to get to this 10th proportion. But I think this was a good enough intro video where it's not spoiling anything either, where you can actually go at this from an intuitive perspective. But I wanted to make a lot of videos, but I did want to make this just like a one click and done. So hell yeah. And so, but if I was right here, this length would have to double and double and double. So this video does not show how to get to there. I thought it was super obvious that the fact that at the beginning you're at least getting a proportion, and as that's being pulled away, I guess, yeah. So no, it's not so obvious of how you actually get to 1/10 towards the wall. I actually thought it would be groundbreaking to figure out how you even got halfway, or even, yeah, how do you get to the halfway? So that'll be for round 2, but I thought this was a good place to start. Hey, once you are making positive ground, what does that look like? And here's like getting over the hump, where your relative velocity, like 1 divided by 10, and if you're at 1/10 the remaining length, hell yeah, now you actually just have solid velocity towards that wall. You don't have any velocity this way. But at the beginning, hell no, you got tons of velocity that way. Like we said, right at the beginning, I'm going 1 meter a second this way, that thing's going 10 meters per second that way. But that's going to slow down. So that relative velocity this way is slowing and slowing and slowing. And then hopefully it gets to where, you know what I mean, it hits 0, and then I finally get over the hump and I'm going that way. So hell yeah, so we showed where you're getting over the hump and going that way, but I think there's still work for me to do to show how you actually get to the midway point. So even though it's lengthening, how the hell do you get to the midway? I'm super curious about that. I thought this was going to be a 5-minute video. I'm glad I found my conundrum, but hell yeah, this is perfect. Go solve it for yourself, but this is, I think you can see from this that if you ever got to 1/10 and your speed was 1/10 the rate at which the band is being pulled, you can see that, hell yeah, now you actually have forward progress. Booyah.